the topic is called finding rational roots, but sometimes you'll see it as the rational zeros theorem, or I've even seen it as like the remainder theorem. So there's a couple different names, but basically you do the same thing with any of whatever directions they give you. And so there's a couple steps that you need to follow. So first, you want to make sure your polynomial is in standard form. So you want to just make sure they're arranged with the largest exponent to the smallest exponent. Okay, so like if the largest degree is 4th, that term's going to go first, then the exponent of 3, then the exponent of 2, then the exponent of 1, and then your numeric term. Okay? Second, you're going to write down all the factors of the leading coefficient, or sorry, of the constant. The constant term is usually the last term. I mean, once you've got it in standard form, that's going to be that number. And we'll call that one P as in Paul. Okay? Whatever number that is going to be your P. Then the third step is you're going to write down all the factors of the leading coefficient. So whatever that number is, that's going to be your Q. So you're going to have a P and a Q. Step number 4, you'll list all the possibilities of P over Q. Step number 5, you're going to use synthetic division to get all the roots. Okay, and so when you use synthetic division, you remember the last number you get should be a 0. If it's something other than 0, then that was your remainder. Remember that part? Okay, so if you get 0, then yes, it's a root. If you get some other number, then it's no, it's not a root. Okay? So let's look at one and you'll see how this is going to work. Okay, because these directions sound kind of complicated until you actually start doing it. All right, so example number 1, we're going to start easy. So there's three examples. It's kind of like easy, medium, hard. Okay? So example number 1, we're going to have 2x squared plus x minus 1 equals 0. Okay? Just make sure it's in standard form. Make sure your largest exponent comes first, then this is x to the first, and this is x to the 0 power. If any of them are missing, you're going to have to put a 0 term in there, right? You guys remember that? Okay? And so you're going to look for your P, the factors of the constant, which is going to be P. So in this case, it's -1. All the factors of 1 are just 1. Okay? And then you're going to, for step number 3, write down all the factors of the leading coefficient. In this case, it's 2. And all the factors of 2 are just 1 and 2. So this one's kind of easy. So it doesn't have a lot of factors. So for P, we just have 1. And for Q, we have 1 and 2. So the possible solutions are basically just going to be 1 over 1, positive and negative, and 1 over 2. So I did 1 over 1 and 1 over 2. But you can see that if there were more P's, you would have a lot more possibilities. And if there were more Q's, there would be a lot more possibilities. Okay? So if you have any of these that are easy, look for easy ones to start with. For instance, 1 over 1 reduces to 1. Okay, so 1 is easier to use synthetic division with than 1/2, right? Okay, so we're going to start with the number 1. So we're going to use synthetic division with 1. We're going to take the coefficient here, which is 2. There's a 1 there that you can't see, and then there's -1. So for synthetic division, you're going to bring down the 2, and then you multiply 1 times 2 and you get 2. And then you add 1 plus 2 to get 3. And then 1 times 3 is 3. And -1 plus 3 is 2. So since there is a remainder, then we know that the number that we tried, the 1, is not a root. Bummer, right? Because once you find 1, it's going to get easy faster. Okay, so we tried +1, but we haven't tried -1 yet because we have that choice. So that's the next easiest one to try. So we're going to try -1, same coefficient, so just copy the 2, 1, and -1. Bring down the 2. And do synthetic division again. So -1 times 2 is -2. 1 plus -2 is -1. -1 times -1 is +1. And then -1 plus 1 is 0. So this one does not have a remainder, which makes 1 a root. Because, oh, sorry, -1. -1 is a root because it didn't have a remainder. Okay? That means this equation, the 2x squared plus x minus 1, we can shrink it down by subtracting 1 from this exponent, right? So now we're going to have 2x minus 1, set it equal to 0. And if we wanted to, we could do synthetic division on this one, but this one's so easy, this is like a pre-algebra problem. You can just go +1 to both sides. You get 2x equals 1. Divide both sides by 2. And our second answer is x equals 1/2. So these are our 2 roots. -1 is a root, and 1/2 is a root. Okay? Now, how do you know how many roots you should have? It has to do with the exponent. So if you go back up to the original problem, what was the exponent? The largest exponent? 2. So you should have 2 answers. And we do. We have -1 and we have +1/2. Okay? Let's try one that's just a little bit harder and hopefully it'll start to help. Okay? Because these are a little bit tricky. All right. Anybody still copying example 1 down? We're good? Okay. Example number 2. We're going to go 4x to the 3rd minus 8x squared plus 5x minus 1 equals 0. Okay? And for our p, we're just going to look at this constant term, this -1 here. And the factors of 1 are just 1 and 1, right? Nothing else goes into 1. But for 4 has several factors, right? Like 1 can go into 4, 2 can go into 4, and 4 can go into 4. Right? Yes? Okay. That means our possible roots are going to be p divided by q. So the easiest one is going to be 1 divided by 1. So plus or minus 1 over 1, which is just 1. Then some of our harder ones are going to be 1 over 2 and 1 over 4. Okay, so if you look at your choices, you've got 1/2, you've got 1/4, but you've also got +1 and -1. So if you have a choice of where to start with, which you do, start with positive and negative 1, right? So let's try positive 1. Then you just, we already sort of did it, but make sure your equation is in standard form. Largest exponent is 3, next exponent is 2, next exponent is 1, next exponent is 0. So how many roots should we have? 3, because it's a cube, right? Okay, so let's take our coefficients. We've got a 4, a -8, a +5, and a -1. Okay, so bring down the 4. 1 times 4 is 4. -4 plus 8 is -4. 1 times -4 is -4. 4 plus -4 is 1. And 1 times 1 is 1. -1 plus 1 is 0. Okay? So we lucked out, right? We found a root right away. So 1 is one of them. So we've got 1. We need 2 more, right? All right, but I'm going to shrink this down, right? Because now I can rewrite this equation with a lower exponent. I can call it 4x squared minus 4x plus 1. Okay? And we still have these choices up here. We tried positive 1, but we can also try negative 1 now, right? Because it's a possibility that it'll work. So let's use those coefficients, the 4, -4, and 1. You could use it on the same ones you did here, but now that we shrink it down, it's going to go a little bit faster, okay? So bring down your 4. -1 times 4 is -4. Add the negative, wait, wasn't that positive? Hold on. Did I mess something up? Oh, did I? Oh, I did the positive. Sorry. Let me just make sure I did right. This should be -8. 1 negative. Did I write something wrong? Oh, I did one twice. Okay. So sorry. Just making sure I did it right. Bring down the 4. -1 times 4 is -4. -4 plus -4 is -8. -1 times -8 is +8. And 1 plus 8 is 9. So it is not a root. Okay? So now let's try one of our fractions. We could try +1/2, -1/2, +1/4, and -1/4. So let's just go with 1/2, +1/2. Of what's left, it might be the easiest. So let's go 4, -4, and 1, because that one didn't work. Okay, so bring down the 4, which is 4. Half of 4 is 2. -4 plus 2 is -2. And then half of -2 is -1. So 1 plus -1 is 0. So this one does work. So 1/2 is our second root. So now we have 2 answers. We need 1 more, right? And because we just found one that works, we can shrink this. So this was 4x squared, so this is going to be 4x minus 2 equals 0. Do we need to do synthetic division on this one? No. At this point, it's so easy, we can add 2 to both sides. Bless you. Divide both sides by 4, and we get x equals 1/2, right? So look, here's a weird one. We get 1/2 and 1/2 twice. 1/2 and 1/2 and 1. So when you get it twice, that's fine, but it counts as 2 of the 3 answers. And we're done. So we don't have to try 1/4 and -1/4. That make sense? All right. I've got one more of these.